Welcome to Real Vision Crypto. I'm Ash Bennington. Today, I'm joined by Corby Pryor, venture partner at HOF Capital, formerly head of blockchain at the same. We talk today about the metaverse, Web3, cross-chain blockchains, decentralized time, and much, much more. Corby, welcome to Real Vision Crypto.
Thanks for having me.
It's a pleasure to have you here. You know, we were talking a little bit off camera. You have a fascinating academic background. Tell us a little bit about what you did before you got into the blockchain space.
Yeah, so I was the first person to graduate with a quantum computing and photonic engineering degree from University of Pennsylvania. How I got there was interesting because I wanted to, coming out of high school, I was very passionate about physics. And while I was passionate about physics, I knew I wanted to make money. So I had to go figure out what problem I should solve that's going to do that. And around 2016, 2017, that was right around the time where Moore's law was starting to slow down. And Moore's law is the idea that the computing industry will be able to get exponential performance out of computers by reducing the size of the individual components every year and a half, every 2 years. But there's a problem with that because there's only so much that you can miniaturize before you hit quantum mechanics and then eventually splitting the atom. So it doesn't make sense for Moore's law to continue forever, which means that the industry has to maintain its performance trajectory. You got to find different architectures. And that was really the problem that I was trying to solve when I first got to Penn. And that led me to, focus on 3 different computing architectures. Quantum computing was the main one that I was studying at Penn. And then I took a look at neuromorphic computing, which is how do we get the architecture of the brain and put it onto a chip, as well as blockchain architecture. So at the time, all 3 of those looked like they didn't work. So I'll start with neuromorphic computing because that one's interesting. The reason why it doesn't work right now is because just like cells in the brain that die, the individual components on the neuromorphic chips die just like brain cells. So there's no way to get brain-inspired hardware that could, in theory, be really useful for AI and machine learning, but just not there yet because we can't figure out how to keep these chips alive. The blockchain I started doing in 2017, primarily from a trading perspective, but then also a bit on the smart contract level. And that was just a really confusing time period. It was hard to see the use case. I had people asking me to do like big peer-to-peer Bitcoin arbitrage with people in Venezuela, and there was false volumes on the exchanges, and there seemed like there was just too much noise and sketchy people at the time, and it was in large part true. It's a completely different story now. And then with quantum computing, which is what I mainly focused on the academic side, I would characterize that experience as trying to get a whole bunch of different types of computers to work when they don't really work.
So I should say you and I met at a party a couple of months ago, and I was just very impressed by your knowledge of this space. But also, you're a young guy, obviously very near the beginning of your career, and yet you already have a track record as an institutional investor. Tell us a little bit about the transition to HOF Capital and what you were so passionate about doing in the investment space.
When I realized that I was too early for all these computing paradigms, the only way that I could really see myself staying at the frontier of tech was through early stage VC. And when I linked up with HOF Capital, that was summer of 2020, the summer of COVID. And I got there. I knew nothing about VC. I did not know how tech companies worked. I didn't understand how much of the world worked, actually. I only understood how computers worked. And so I credit those
It's a pretty
guys
good
for
start,
teaching me. Yeah, I got super lucky every single time. Those guys gave me a really great foundation. in terms of just how to evaluate companies. And it's been an exciting ride. When I got there that summer, it was around a 40 million AUM fund. And as of today, it's, I think, over 1.1 billion. And we didn't really scale our team with the AUM. So it's been very crazy.
So let's talk a little bit about the technologies you were investing in. I mentioned at the beginning of the show, Metaverse, Web3, cross-chain blockchains, and decentralized time. Talk a little bit about those areas. There are obviously some things that are very much kind of ahead of the curve right now that people who are really interested in the space from the computer science side are talking about, but are still not yet broadly known outside of the digital asset space. Tell us a little bit about why those things are so significant.
I think it's helpful to contextualize some of these focus areas within the history of why Bitcoin was created. And ultimately, it was to create a better financial system that was secure and trustless. And what really opened up my eyes during my experience at HOF was when it was during DeFi summer, which for people who weren't there, it's like hot girl summer, but for crypto nerds. And I was trying to wire money on a weekend from my bank account to do some interest rate arbitrage on Aave and Compound. And when I realized that I had to wait until Monday for the bank to open, I realized that the blockchain financial infrastructure was going to be the design that wins out. And so when we're designing financial infrastructure, we have to make sure that the system is as secure as possible. We cannot build janky technology. What happens when you build a janky technology or janky infrastructure is that you have something like 2008, where basically a collapse of an entire system that was basically the biggest rug pull in human history, with 10 million people losing their homes. And when we're building Web3 and the metaverse, we have to make sure that that can't happen again. And we're unfortunately in this weird position where we are designing systems that might fail and are somewhat failing. You guys, I know that you were talking about this with Robin and Camilo on a podcast last week about Solana wormhole being bailed out by Jump Capital. Not every single bridge is going to be able to be bailed out by Big Jump.
So let me just give a little bit of a context here for people who may not be familiar with the story. So what Corby's talking about here is this idea that there was a significant failure in Wormhole. This was a bridge between Solana and Ethereum, a cross-chain bridge where assets could be transferred across. It was a massive failure. I forget the exact number, but it was into the hundreds of millions of dollars, $200 or $300 million lost, and it was ultimately backstopped by Jump Capital. Corby, one of the things that I think people who don't have your computer science background struggle with is understanding what the challenges are in building these systems in layman's terms. Why is this so complicated? Particularly these cross-chain bridges seem to be major material technology problems that just haven't been solved yet.
Absolutely. It's one of those systems that I think the space as a whole hasn't really been able to diagnose the problem. Because originally when we were talking about crypto interoperability, we were thinking about getting tokens from point A to point B. Now, you can get tokens from chain A to chain B, and no problem. It's actually not that complicated. But to do it in a secure way, that's the problem. That's the challenge, right? So if you wanted to send cash from a bank, from two different banks, you send an armed car with armed guards, and it's a very robust process, because if you send that millions of dollars in a golf cart between banks, it's going to get robbed or exploited. The problem here is that we have not figured out how to secure the communication channel between two blockchains. And the way that I think about it is that a blockchain is a database, and the database stores assets. and these assets need to be secured somehow. So what is actually securing it? Well, it's the consensus layer built into the protocol. And the way to think about the consensus layer is that it is code that sets the laws and the rules of the network. So everything that happens within this consensus layer is allowed to happen and is safe and secured. And the way that these laws of the consensus are enforced are through the decentralized validator nodes, which are constantly checking every transaction to make sure that it is in accordance with the law, effectively. What does that mean for cross-chain? If we want to have secured communication between two different databases, then we ultimately need to have consensus layer that's designed to regulate the laws between chains. So if we, in the wormhole hack, there was nothing went wrong on the Ethereum side. The consensus, the security was maintained. Nothing went wrong on Solana's side. Security was maintained. But the problem was that there was no consensus securing the transactions between the two. So how do you actually go about fixing that? Is that you need to build a cross-chain bridge directly into the consensus layer of these protocols. And what that looks like is, instead of a validator node just validating and coming to consensus on transactions in the network, it's also validating, improving the state of the other chain. So if you're writing validator, if you're a validator node, you have to put some code into your program, and the only way to secure a bridge is if you just take the code for a bridge and you put it into the validator node itself. So its job is to maintain the laws of the network it's operating on, as well as the laws between different chains.
So basically what you're saying is you've got these two protocols. You've got Solana on the one hand, Ethereum on the other, both working within relatively secure consensus layers, maintaining consensus, maintaining security for those transactions. But when you try to build a bridge between them, effectively you have this weak point in the middle that becomes something that hackers can exploit. And the challenge is trying to integrate that consensus mechanisms so that they're working in a way that is parallel and congruent, so that it can secure not just sort of the from layer or the to layer, but also the transfer in between. I'm someone who does not have a computer science background, but that sounds like a pretty significant undertaking from an architecture perspective, figuring out how to basically unify these consensus protocols so that two disparate networks, two disparate tokens can maintain security in a secure and integrated way. How close are we from getting there? I just looked it up, by the way. It was a $320 million hack. So just so people understand, this is a considerable challenge, not just on the computer science side, but also financially. These vulnerabilities, these exploits can be just enormous.
And there's going to be a lot more of them. I was looking at a list of 40 different bridges. 30% of them had already been exploited. And I would have liked to exploit the other 30%. Because they are very vulnerable and very weak and have billions of dollars of assets stored in sometimes just one computer.
So just to underline what you just said, you're saying that essentially there are billions of dollars of assets out there that are potentially going to be exposed to vulnerabilities, critical software vulnerabilities, because of the architecture of these cross-chain bridges.
So this actually reminds me of 2008. For people who watched The Big Short and can remember the scene with Steve Carell talking to the CDO manager, and he's saying, wait, so you're telling me CDO A is part of CDO B, which is part of, CDO C, and you're calling it CDO squared? And he's like, that's crazy. And the CDO manager says, no, that's awesome. And it's not awesome. Essentially, it's like 2008 in the sense that people are staring directly at the problem and no one thinks it's a problem. So I was talking to a lot of investors about how these bridges are going to fail. a couple months ago, and that we really need new interoperability solutions. Most investors were under the belief that interoperability has been more or less solved because their DeFi applications that they invested in, they're getting cross-chain liquidity, right? Tokens are going from point A to point B, and everything seems fine. But ultimately, there's a deeper issue where people are coming in, building bridges that are secured by just one computer. So they're not even decentralized. Everyone knows that this is the case. And I'll create a blog post to show some of the interactions that we've had with the bridges. But no one seems to care that $5 billion of assets are stored on a single computer controlled by a couple of people. And I think primarily because people are getting their tokens from point A to point B, but it'll eventually fail.
Yeah, I mean, this is a pretty extraordinary statement. What you're saying right now is that just because effectively these things are working in kind of a janky way, because there hasn't been a significant focused attack on some of these systems, people are assuming that they're secure when they're not. This is a pretty, I think, intense claim, particularly coming from a young guy who's familiar with all of the underlying technologies. Typically, you think it's the other way around. It's the crusty old investors who are worried about it, and the young tech savvy guys are saying, "Don't worry, this is secure." But you're effectively saying just the opposite. Your analysis of these bridges suggests that there are going to be potentially much greater losses in the future, unless I'm misunderstanding that.
You are understanding correctly. They're not designed in a secure way. And I would say the rule of thumb for security in decentralized systems is that if it's not secured by consensus, it's not secure. It's exploitable. And so that goes for the bridges, that goes for the oracles, that goes for the file storage. All of that will eventually need to be brought under consensus in order for it to be secure. Unless you don't care about security, and for some instances, it's less relevant. But when we're talking about billions of dollars of assets, we need to treat this seriously, because we're ultimately designing a financial system that's supposed to be better than the last one. And that can't involve putting people's assets at risk. It can't be falsely advertising a decentralized version and convincing traders and users that ultimately your platform is secure. It's a bit irresponsible, and the only way to really solve it, I think, in the short term, is probably a couple more failures. Where it's unfortunately, I think we're gonna have to feel the pain before we actually solve the problem.
So let me just walk through this, because it's complicated from a tech perspective, and I want to make sure that people understand what we're talking about here. So the consensus mechanisms are things like proof of work and proof of stake, delegated proof of stake. These are all the consensus mechanisms you've probably heard about already in the context of Bitcoin or Ethereum or some other protocols. What you're suggesting is that these bridges are not governed by the same consensus protocols. They are essentially outside of consensus, and therefore there are weaknesses, not just in bridges, but in other types of cross-chain technologies, also in oracles, which are effectively decentralized systems that are signaling states that are present in the outside world. In other words, telling blockchains about things that are happening off-chain. This is a very significant concern. Give us a sense of what percentage of these out of consensus mechanisms are responsible for doing some of these cross-chain functions. In other words, how big is the problem in terms of the current system today?
I would say at least the majority of the bridges are compromised and are prone to being exploited. There are some bridges and some new protocols that are coming out that have built bridges within their consensus layer. Two of those projects include Flare and Crypto. And full disclosure, I invested in both of them, primarily because I believe in their interoperability infrastructure.
We've talked about some of the risks and downsides here. Give us a sense of what the upside potential is for these cross-chain applications and why they're so important to be developed.
Absolutely. So the reason why solving this problem is so important is that it will be the dividing line between this era of crypto and the era where mainstream adoption really happens. Because the main problem right now for mainstream adoption is that crypto is too confusing. The user experience is crappy and the stuff is complicated. People ultimately shouldn't have to know how this works in order to use it, just like people don't know how the internet works, but they can use it. And the way that we solve this is going deep in the stack and solving the infrastructure that's holding everything together. Similar to how we were using landlines and dial-up internet as an intermediate form for internet communication. We're sort of in that moment in time where we're still using old infrastructure for the new internet. And when we solve this problem, essentially, we're going to be able to abstract away this whole blockchain layer because we'll be able to have single applications or software kits or APIs that can interact with all these chains in a secure form. It'll be complete unification of this layer to allow much more complex applications in Web3 and the metaverse to build user experiences that don't involve switching between chains and using MetaMask, seed phrases, private keys. All of that can go away if we secure this one layer and unify it.
So let's switch gears here a little bit and talk about Web3 security implications. And also, let's begin with the most general framework. What's your definition of Web3?
My definition of Web3 is it is the next layer of the internet. And I'll break, obviously, that's kind of a cheap way to define it. But what Web2 is and the internet in general is just protocols stacked on top of each other, different layers of communication protocols. And so for Web3, we are adding a new protocol, which is the blockchain layer. And it's really interesting for Web3 because we are in this moment in time where we've had all these different new technologies evolve independently of each other, and they are now converging to be a single system. For Web3 in the metaverse, that really looks like taking video games, blockchain, AI, art, music, the financial system, and putting it all into a single layer for seamless interaction. And that right there is going to be a massive opportunity.
So one of the things that I know that you're incredibly interested in is this idea of decentralized time, which sounds like an incredibly abstract, almost science fiction-like concept. What does it mean, and how does it integrate into Web3 technologies?
For sure. So as a physicist, I've always been obsessed with time because time has always been one of those concepts that is always difficult to get under our control. Figuring out decentralized time in the context of blockchain really was motivated by the idea of solving the portal problem. And what is the portal problem? Like, how do we get users to safely portal between a metaverse on Solana and a metaverse on Ethereum? Everyone's going to be using portals in the metaverse. It's going to be the transportation network. But if we want to figure out what time someone portaled, and that's going to be relevant for making sure that there's no double spend scenarios where someone's assets are being rendered in two places at the same time. In order for us to keep track of to have an orderly account of those cross-chain events, there needs to be a single source of truth of time. And what I mean by that is, and why we would need that is because Ethereum has its own clock. Solana has its own clock. If those clocks differ, there's no way to verify which clock is correct. And it's the same thing in regular computers where ultimately there's a single master clock that is telling everyone what time it is. There needs to be the same thing for that in blockchain, because there's also a problem where in the metaverse, there's actually a lot more clocks in all these different computers than we're really aware of. There's game clocks, there's server clocks, there's blockchain clocks, and it's just generally confusing what time it is in the metaverse. And so having a single source of truth of time can help unify and synchronize the transactions, and ultimately probably be used to provide an extra security layer in terms of being able to track when things happened, making sure that things were done in the correct order, so there aren't situations like front running or MEV trading strategies.
Corby, I know we've talked about a lot of different technologies today. As we come to the conclusion of this conversation, final thoughts, key takeaways for our audience.
I would say, so main takeaways are there's a lot of work that needs to be done in order for the metaverse to realize its full potential. The two main things that need to be solved, in my view, are one, secure communication between blockchain databases, which is effectively solving the wormhole problem to make sure that never happens again. The other problem that is on the horizon is making sure that we all are on the same page about what time it is. And that's going to come in the form of a new blockchain that is acting as a master clock that everyone can reference when building applications. And once you solve the communication problem and the time problem, you've got a pretty good foundation for a massive metaverse economy.
Corby, very well said. Some sobering thoughts about the nature of these potential vulnerabilities. We really appreciate you joining us here on Real Vision.
Thanks for having me. Pleasure.
Thanks for watching, everyone.
Hey there, visionaries. Your free membership to Real Vision Crypto, the world's premier source for cryptocurrency and digital asset analysis, is available right now at realvision.com/crypto.